When designing parts in sheet metal, connecting multiple bodies in an assembly can sometimes be difficult. In this lesson, we're going to go over an alternative to threads, insert hardware. So let's get into it. In the last lesson, we left off talking about how to add threads to our internal holes on our parts in sheet metal. Now, with that being said, as we thinned out those parts, we talked about how those peaks and valleys become less and less depending on our number of peaks that we have in our thread count. And if we get too low, say down to 2 or 3 threads, we risk the idea of having them pull through when the bolt is applying pressure to them, also known as stripping them out. Now, what's a great alternative to that is press-in hardware. So let's come over to the board and talk about that. Now, press-in hardware or insert hardware is a great alternative because it is applying a mechanical bond between a secondary piece of material to your sheet metal. Now, that might sound a little bit complex, but what ends up happening is that you are essentially just crimping them together and the little teeth bite in and it holds the nut or the standoff or whatever threaded body that you're wanting to put into your sheet metal. Now, we're going to use PEM hardware interchangeably here. This is SendCutSend's manufacturer of choice that we end up using. This is just like Kleenex. It's just a brand name that we use. So PEM hardware equals insert hardware. Now, why do we use insert hardware? Well, I already touched on the first one, which is it's a great way to put threads into a thin piece of material. But a great alternative also is that it requires less tooling on assembly. You don't have to have that secondary wrench to either hold the nut or the standoff or stud. And it makes assemblies faster and easier when it comes down to manufacturing. So when we start talking about DFM in our previous lessons, this is a great way to actually reduce assembly time, making things cheaper and more efficient. So this is where all this stuff kind of ties back together. Well, it also increases your capabilities of having different three-dimensional shapes to your sheet metal parts. Now, standoffs are a great alternative to that. Now, we haven't really talked about standoffs, so let's jump over here to the main types and talk about the different kind of shapes and sizes. There's 3 main types when we start talking about insert hardware. We have studs, which studs are just a threaded body, just like a bolt, and it's crimped on through the part. And we're going to talk about the pull directions here in a second. The next one is a nut. So a nut is just like you think about it. It's just essentially a crimped in nut on the backside. This is something that you don't necessarily have to have the wrench, it just has threads, and it increases the amount of threads that you have in that area. And the last one is a standoff. Now, this is where I was kind of getting to the point where it increases our capabilities. If you go all the way back to chapter 1, where we were chapter 1 and 2, that we were doing our Arduino 3D printed box, we ended up having to space that Arduino up off the bottom of that part. Now, standoffs, if I was doing this in a sheet metal body, these are a great alternative to being able to space that Arduino up off the bottom. They come in a multiple different thread shapes and sizes, so I could have this be a 632 or 1032 on the ID, and then it's pressed through, and I am allowed to mount my board on the top while my sheet metal is spaced down below it. This is a great way to add 3 dimensions to your part without bending or forming it. Now with that, they all come in different types of materials. The standard materials that you're going to end up seeing are stainless steel and then zinc-coated steel. Now there's a time and place for each one of these. Certain materials don't react well with other materials, and so you're going to end up seeing stainless steel in stainless steel parts, and then the zinc-coated steel in the aluminum and your other steel options there. And that's because the zinc can react improperly with the stainless steel. When we talk about designing with intention and stuff in the background, if I was to be designing, say, something for a kitchen where everything needs to be food grade, quality, where I can clean everything, then I would be designing in stainless steel. And then I would use stainless steel hardware in that, so everything falls within that same grade. Now that we kind of understand the different shapes and sizes, there's a pull direction that we need to understand that's going on in the background, because since these are crimped in, if you're pulling them apart or out of that crimp, then they're not going to hold up as well. Now with that, I'm going to end up kind of just drawing on our main types that we have over here. This first one being a stud, what ends up happening is if I have my material that it's getting pressed through here, it gets pressed through that body this way. And that crimp happens in this lower section here. And so if I ended up putting, say, my nut or something on here, and I pushed down, I'm pushing that crimp out. The direction in which this needs to be pulled from is going to be continually through the part. So my mating part, my nut, is going to be pulled up. If I am looking at the nut, the same thing happens here. If I have it getting pressed through, what ends up happening is I press it through this way, but my pull direction needs to maintain that same pressed direction. So that's, as we're going to kind of go through this, the standoffs are the ones that end up normally taking the brunt of the load of being kind of improperly used, because you are bolting on something here. Well, the press direction is coming up through the part again. That one's going to go through the part, and you have a great alternative of being able to push it back out. A great way to see this stuff is that if you go onto the guidelines on SendCutSend's website, each one of these hardware in the catalog are going to show you the proper push and pull direction and the insert direction, and you'll be able to understand that a little bit better there. Also in that SendCutSend catalog is you're going to be able to see all of the options that they carry, as well as if you go to PEM's website, they have a full catalog there that are a great way to see everything that you can end up using on your designs. Now, one big important thing that we need to note is that we need to space these out from other features and how this is actually done on the shop floor. Now, these are done through a pressed process, right? We talked about crimping these in, and it's done between two anvils, right? So we have an upper and a lower, which the uppers or lower is going to be holding that hardware, and the other one is going to be pushing that material into that hardware. Now, with that, though, is that we need to have access from the top and the bottom. And we have a machine that wraps around that part. So just like this, we call this depth right here the throat. Right? So that throat dictates how far into the part in which we're able to do PEM hardware. Now, SendCutSend has great machines that have really deep throats, but what ends up happening here is that we're still limited on the part size. So when you start seeing max part size, that's going to be your limiting factor. The minimum part size on the flip side of that is that we need to be able to hold the part inside the machine. So that's how those numbers are going to be dictated there. Again, when you're designing, you should understand the max and minimum requirements of all of the operations that you're going to put into your design so that you don't get a kickback on the DFM side. Where we end up seeing right here, though, is that since it has to have both sides, we also have to have clearance from other features. And the spacing or the size of these anvils change depending on which hardware that you're doing. And so with that, the best way to see that is go to the guidelines on SendCutSend's website. They're going to tell you that minimum spacing between the hardware and other features. If something is in here, say we have a dimple like right here, what's going to end up happening is one, it's going to fail DFM, and if it does get through, you're going to see a deformation in this area because now you're applying force next to that dimple, and you're going to end up seeing the dimple get messed up. So that's that situation. Since it requires both sides to be accessed, if you end up having a bend, especially an acute bend, let's say our part does this, right? If I have that acute bend and I'm trying to put this in here, I can't get my top anvil into that situation. And so it makes it so that the part is not necessarily able to be manufactured. Now you might say like, hey Jake, like why don't you just put in the hardware before you do the bending and then you can bend it. The problem is that this hardware can also get in the way of your punch and your dies. So say my punch is coming in this area, it's going to make contact with the hardware, so the nut or the standoff, and I'm not going to be able to make it. So minimum distance to other features like bends, dimple dies, other hardware is going to be critical, and you need to understand that is a thing that you need to build into your designs from a DFM standpoint. So with all of that, we're going to end up taking it down here to the last things, which is warping can occur, right? We are putting pressure into the parts. We're deforming them in that area of the hardware. And if we put in a lot of hardware, I'm going to grab this little part right here. So I have a lot of studs. They're large studs on a thin piece of material. I can see a little bit of warping in this part purely because of all of the stress that we're putting into the center of it. Now these are studs. This is something that can be straightened out. We talked about in dimple dies that you can put bends back into your parts to add that backbone, straighten them out. But just know excessive stress is going to lead to warping. And then the last thing is that finishing. So finishing can be done before or after, depending on the type of finishing. Now when it comes to powder coating, we're going to insert the hardware first, then we're going to put it in through the powder coating process, and we're going to use protection like thread protection, where we're going to use plugs and caps to cover those threads so you don't have to chase them later. Now with anodizing is a dip process that's going through a chemical change. That anodizing process has to be done after, or the threads are put in after the anodizing process because they'll react improperly during it. So hardware is after anodizing, before powder, and that's what you're going to end up seeing when you get your parts. So quick cut, I actually forgot to, when we filmed this, go to CAD and show you guys how to do that. So let's jump onto CAD right now and get to showing you how to insert hardware. Now I pre-drew a rectangle or a square here, and what we're going to do is just add 4 holes to those corners. Remember that in the background, SendCutSend is going to resize these holes. I like to try to make them at least close to the size of the hardware that I'm going to be putting in. It kind of shows me the spacing from the hole to edge as well. On that, I created a sketch. We're going to go to offset and create an offset here. This is a quick way to put 4 corners with holes in them that is equal spacing from the sides. We're going to say minus 0.5, and that essentially makes it so I'm 0.5 from this edge down and 0.5 from this edge over. Let's go ahead and finish our sketch. And we have those 4 points now available to come over here, go to solid, and use the hole feature. We're going to click on each of these 4 holes. Remember, these holes are not the size that we want currently right now. Once I have that, we're going to make sure that we're on simple hole all the way through, and we're going to change that dimension to, let's say, 0.201. That's the through size for a 1032. Clicking OK, we now have 4 holes in each one of our corners. We can go ahead and create that DXF and take it to SendCutSend's website. Now that we're on here, we're in the hole feature adding. We can open up the PEM side or the hardware and see the full catalog that SendCutSend has to offer. We can also see that we can choose from nuts, studs, and standoffs. From this, we're going to add just nuts to these, and we're going to add that 1032 that I just talked about. We're going to choose up or down depending on which side we want the pull to come through. On this part, it's pretty easy. It's symmetric, so we don't really need to care on which side it is, but just know that that's a thing. Now, it's that easy to add hardware to our parts on SendCutSend's website. Just make sure that you have that hole spacing away from the edges and the direction correct. Now, that's it for this lesson. In the next lesson, we're going to start diving into finishing, starting off with deburr. So we'll see you on the next one.